Hello all, this video shows an demo video for an kernel function, polynomial kernel function with SVM. Already with the same code, we have worked with some other three different polynomial kernels in SVM like linear kernel, then radial basis function kernel and sigmoid kernel. In this work, we are going to work with polynomial kernel and we are going to make an comparison that which kernel is going to provide the better results when with SVM. So with this code, we are working with the heart disease data set which we have downloaded from Kaggle. You can just give us heart disease data set detection, heart disease detection Kaggle. So this data set will get downloaded. It is having nearly 14 entries. Among that, the first 13 entries we will be using for the y variable, and the last one variable, that is the target variable, we will be using as the y variable. Then we are getting the info of the data set, everything as integer and float only. Then we are getting checking whether his data set is having any null values. Why? Because if it is having any null values means we have to work with any pre-processing functions, but since our data set is not having any null values, we can omit this pre-processing algorithm. Then we are checking the shape of the data set. Then we are making a plot of the target variable, but the target variable is having nearly two classes, that is 0 and 1. Within this plot, we are making how many 0 entries and how many 1 entries are having and which one entry is higher. Then we are making use of the train test split function by using the x variable and y variable. As I said, the last variable we are dropping for the x variable, only the last variable we are using for the y variable. Then we are using the train test split function to, and also the x and y variable with the test size of 0.2, that is 20% for testing and remaining 80% for training, to determine the variables like x train, x test, y train and y test. And then we are working with linear kernel SVM. So for that, we are importing the library which we are going to use for SVM, and within the SVM library, we are importing a function called using the kernel function, and in this thing we are using linear kernel, and we are using fitting function to the for training by using the training variables like x train and y train. And then we are using the predict function for testing with the help of the test variables. And we are getting a prediction variable. That variable we are using to determine the confusion matrix plot and also the classification report. So this is the confusion matrix plot by using the prediction variable and also the test variable. Then classification report is also taken by using the prediction variable and also the test variable, and we have got an accuracy of 86%. Same as such for sigmoid also we have worked here. In the place of linear, we have replaced sigmoid and we have got an accuracy of nearly 58%. Then we are working with the radial basis function kernel, and with that we are using the kernel as RBF, and we have got an accuracy of nearly 76%. Then in this demo, we have worked with polynomial SVM. For that, we have given the kernel as poly, and then we are using the fit function and the training variables for training, and the predict function and the testing variables for testing. Then we are getting that output within a variable called prediction SVM P, which states a prediction SVM polynomial kernel function. That prediction SVM kernel we are using to plot the confusion matrix and also the classification report. Since the y test variable, that is the testing, consists of only 20% of data, here the confusion matrix is using only 20% of the data, and the remaining, if you want some values in confusion matrix means you can just change the ratio like 50-50 or 70-30 as per your wish. Then we are getting the classification report and has got an accuracy of nearly 72%. Then we are making a comparison. For making a comparison, we are determining a variable called models, and within the models we are determining the different SVM functions, SVM algorithms which we are using like linear SVM, sigmoid SVM, radial radial basis function SVM and polynomial SVM. And then we that this models we are making in an for loop, and within the for loop we are training the model, testing the model, and then determining parameters like accuracy, mean square error, and R2 square error. And also we are declaring or printing the training accuracy and testing accuracy of every models. And we have got the training accuracy and testing accuracy of every kernel SVM models within the single cell. From here itself we can notice that linear SVM is providing better results when compared to another SVM, but still we are making a table comparison, and within the table we have made a highlighter point in which the model with the best accuracy will be shown with the green color, and the model with the least accuracy will be shown with the red color. So from this thing which we can able to justify that the linear SVM is providing better accuracy when compared to the other SVM. And after linear SVM, the radial basis function SVM takes the place. Then comes the polynomial SVM, and finally the sigmoid SVM. So this is the details regarding the different kernel functions with the heart disease data set. In the next video, we will be working with another kernel function with SVM. Thank you.